Hello again, Dr. Lee Newton here, back for part 2, a deeper dive into indoor air quality issues. And you're back as well, so thanks once again for listening, paying attention. Evidently I didn't put you to sleep, scare you away with part 1's video, so thanks again. Let's get right into it. Particle size, HEPA, MERV, we're going to dig into what's in my air, how small are these particles, what do these acronyms mean, and what else do I need to know to have indoor clean air. Let's take a moment first and review the metric scale. So the base word of a unit of length in the metric scale is meter, but that's a pretty big measurement. Humans are 1 to 2 meters in size generally. So if you put a prefix in front of the word meter, then it means something smaller or bigger, but in this case smaller. Deci is 1/10, centa is 1/100th, milli means 1/1000th. So there's 1,000 millimeters in a meter. But a millimeter itself is still a pretty big measurement when it comes to particle size. So then we go another 3 decimal places over and we go to micro. That means 1/1,000,000th. There are 1,000 micrometers in a millimeter and 1,000,000 micrometers or micrometers in a meter. So a micron, micrometer or micrometer, micron, let's use that term because it's 2 syllables instead of 4, easier to say. That is a basic unit of particle size. Most of the particles that we'll discuss can be described in units in terms of microns. There are a few examples of even smaller particles. Let's get out on in the open. A nanometer is 1/1000th of a micrometer, so then there are a billion nanometers in a meter. So if we look at microns, there's 1,000 nanometers in a micron. Picometers, another factor of 1,000. Now you're getting into sizes like individual atoms and bonds between atoms and so forth, and it's very, very, very small. Some of the various particulate matter and contaminants that are in our air can be, well, they all can be defined, but some of them that are more common consist of dust mites. They're 300 microns in size. Pet dander, 2 to 10. Cigarette smoke particles, about 1/4 of a micron. Household dust, 1/2 micron and larger. I mentioned acrolein in the previous video. That is an organic compound that is a byproduct of cooking, essentially. 2.5 microns or less, and if you see the term PM2.5, you're looking at, they're referring to all particles 2.5 microns or less in size. They're not specifically saying acrolein. That's simply one of them that fits that size description. Bacteria are about 5 microns plus or minus. A virus is 5/100ths of a micron or 1/20th of a micron. Now, some more commonly known reference points, human hair, if you have it, it's about 75 microns in diameter. Red blood cell about 5. Concerns are with 10 microns or less, they're inhalable. And then even more concern is with the PM2.5 because that's a size that can get into your lungs and your bloodstream and go to other areas of your body and wreak havoc, cause damage, make you ill over time. More about acrolein. Again, the primary source is cooking. It was used as a genotoxic tissue irritant and a nerve agent in World War I. So you don't want that in you. So since the primary source is cooking, then you need to have a range hood. Okay, don't cook indoors without a range hood. Don't have a simple filter range hood. Why? Because it won't get clean. Simply because there's no incentive to clean it. You don't know if it's clean, you don't know if it's dirty. You turn it on, is it working, is it not? Studies show that an exhaust range hood works way better for our indoor air quality. Also be aware that there is a wide range of quality and efficacy and efficiency. There's a study that looked at 7 models of exhaust range hoods varying in price from $40 to $650, and capture efficiencies range from 15% to 98%. What I didn't include there was that it was not a direct correlation between cost and capture efficiency. So you need to do your homework when you get a range hood. Make sure it's an exhaust range hood, and do your homework. Look for independent studies. Try to avoid the marketing hype there. But please have one. Now, in order to discuss other aspects of indoor air quality, we need to define a term called the DALY, and that is an acronym that stands for Disability Adjusted Life Years. So when we're trying to quantify the effects on human life of poor indoor air quality, we need a way to quantify it, and the DALY is the way that the researchers have chosen to quantify it. So it's the sum of years of life lost prematurely to death, along with years of life suffering a disability. So you live with a disability or you die prematurely, all those years added together, that is a DALY. Now, Dr. Brett Singer from the Department of Energy lab at Berkeley is a very smart person. He's one of the ones that I pay attention to. I always feel that if I'm the smartest person in the room, which never happens anyway, but if I am, I'm probably in the wrong room. I like to pay attention to those that are a lot more experienced, a lot more intelligent than me, and that's how I learn the best. But he did a presentation that will be in the list of references at the end of the video. It's about an hour long. It's a very good presentation. This slide was borrowed from it. The particulate matter contaminant that affects health the most is that category PM 2.5, under which you have the acrolein. As I previously mentioned, you've got formaldehyde, radon, mold, moisture, secondhand smoke. That is the big category. So we got to make sure that we're hopefully not producing things like secondhand smoke, and hopefully your house doesn't have radon. And if it does, you're getting rid of it, you're filtering it, you're exhausting it. Now, Jennifer Logue back in 2011, 2012 did a couple studies, and they concluded that in residences, so where we live, there's an average of 1,100 DALYs lost per year per 100,000 people for poor indoor air quality, but that includes the effects from radon and secondhand smoke. So that's pretty huge. And then a Berkeley study looked at offices and schools and found between 140 150 disability adjusted life years lost per year per 100,000 people. The difference between 1,100 and 150 is thought to be because we spend a lot more time in residences than we do in offices and schools, simply put. Now, look at this fireplace, and it looks kind of inviting if you're watching this on a cold winter day. What don't we know about this? What is not readily apparent from the picture? And whether it's combustion or not. In other words, is it a fireplace that burns natural gas, propane, some fuel source, or is it an electric fireplace? Now, it kind of looks like a flame to me, unless it's an electric fireplace, and some of the newer ones are getting really authentic. So, I mean, it could be, but you don't know if it's combustion or electric. You don't know the fuel source, and you don't know if it's vented or not. Now, by saying vented, I mean that if it's combustion, the products of combustion, okay, so you get heat off it, but you also get other products of combustion. You get carbon dioxide, carbon monoxide maybe. You get moisture in your air. Vented means you're venting those products of combustion outside your living space. Unvented means you've got a fireplace that's sitting somewhere in your room and it simply burns and the heat and all the stuff come out at you. And so one word about unvented combustion fireplaces: don't. Simply put, don't have them, because they're not good for your health. They're not good for the health of your house either. You can contaminate your house and make things wear out faster in terms of your wall coverings and your paint and whatnot. So don't do that. I wouldn't have one at all. Now, there is one semi-exception to this, and some of the newer combustion fireplaces burn denatured alcohol. And if you burn denatured alcohol in a fireplace and you have enough oxygen in your air so that complete combustion can occur, then you're not going to get some of the more hazardous particles. But how do you know for sure? I wouldn't have an unvented fireplace at all. I wouldn't have an unvetted combustion fireplace. Now let's talk about filtration. I made up two terms for ease of understanding. I don't know if they're legitimate terms or not, but they are for the purposes of this presentation. We're talking about physical filtration, as when air is drawn through filter media and stuff is filtered out of it. Stuff like dust particles and whatnot. It depends on how tightly the filter material is woven together in terms of how small it can filter. So the lower limit, if you're talking about HEPA, which we'll define here in a few minutes, is 0.3 microns, and then there's hyper HEPA, which is 0.003 microns, or 3 nanometers. But there are many particles, the ultrafine particles, the fumes, the VOCs, the real tiny stuff that's measured in nanometers to picometers. You can't get a filter that filters that small with a physical means of filtration. So I've used the term chemical filtration here to denote when the extremely small particles, like those measured in nanometers to picometers, are removed from the air, but it is done by not absorption, it's done by adsorption, adsorption. And so it's a chemical process where electrons are exchanged, and it involves an activated carbon or charcoal filter, and you have the molecules or the individual atoms sticking to that filter via electron exchange, because again, they're too small to be removed by an ordinary filter. So HEPA stands for high efficiency particulate absorbing, and the HEPA standard is 99.97% efficiency at 0.3 microns, developed by the U.S. Army Chemical Corps in 1940s, and it's essentially hospital grade application. Now you might argue that, well, wait a minute, I have a room air purifier that says it's a HEPA filter. They're pretty common, and yes, they're possible, but what I'm getting at here is that it is not possible, or I guess it's possible, it's probably not practical to have a furnace system in your home that's HEPA grade, because the equipment that you need to do that is not practical to purchase. Okay. Now let's talk about MERV. And MERV was, the acronym stands for Minimum Efficiency Reporting Value. It was developed by ASHRAE in 1987 as a way to help individuals discern how efficient their filters are. And it ranges from MERV 1 to MERV 20. And up in the upper end of that scale, MERV 20, now you're getting to HEPA grade. But again, your household furnace is not going to have a MERV 20 filter. It's simply not. Mostly you're probably going to have somewhere between 5 and 8. Let's talk about that third line under MERV is a little bit dense. Let's pick it apart. 3 to 10 micron size, a MERV 8 filter is 70% efficient, MERV 11, 80 to 85, MERV 13, 90 to 98% efficient. And furthermore, MERV 13, which is becoming the recommended standard at least for commercial and healthcare settings, it's 90% efficient at 1 to 3 microns, which is very, very good. Now MERV 13 is also 50% efficient. That doesn't sound very good, but hear me out. 50% efficient at 0.3 to 1.0 microns, that HEPA level. So you think, well, gee, 50% isn't very good, but if the air cycles through 4 times, now you're up in the 90%, because the first pass you get 50, second pass you get 50% of the remaining 50, which is 75, and so forth and so on. Don't take this information that I'm giving you and say, gee, I need to upgrade my filter from whatever it is to a MERV 13. The reason for that is the denser the filter material and the more tightly it's woven and the more it filters out, the more it impedes the flow of air through it. So you could conceptually, you could upgrade your filter without the right knowledge, and you could create a constriction in airflow, so then you won't get the conditioned air as much in terms of cubic feet per minute out in your diffusers. You could also burn out your blower motor, and I don't want that to happen because of information I gave you. So the bottom line is consult your HVAC professional with regard to what MERV you have, what MERV you could have, and if you could upgrade without destroying your equipment. Very important. Now, there are other systems that I've come across that, to me, do nothing more than confuse people. I have nothing against Home Depot, but I was kind of intrigued by their filter rating system, FPR, higher filter performance rating, a proprietary rating system developed by Home Depot to best account for the performance of an air filter. So are they in effect saying that they're more effective, they're a better, they have a better way to define filter performance than ASHRAE. Really? I think that this does nothing but confuse consumers. That's my opinion. And I think that whole maneuver was a sophomoric blunder. But again, no offense to Home Depot. I shop there. More on filters and air cleaning. We talked about the higher the MERV rating, the better the filter, but you can constrict airflow and consult a professional before you do it on your own. UV lights. I've had UV lights in my home and my commercial HVAC systems for years. They kill small things as air passes by. Now, there are data that are mixed on this. Some studies show that people that have asthma living in a home that had a UV light in the system had better air quality and resulted in fewer symptoms. There are other studies that showed little effect. I'm reading some articles now in the COVID-19 era that some of the professionals are recommending them more now. So I have them. I think if it could help, I want the best, but I'm not saying that I have all the data because I don't think anybody does. One thing that's important about UV lights is the wavelength of the UV needs to be around 254 nanometers or pretty close to that. If you get down to 185 nanometers, what you're doing is creating ozone, and you don't want to do that. Now, the next topic talks about air scrubbers, which make ozone. So these are being hyped by some HVAC professionals now, and I've heard good things, but I haven't seen the raw data. I haven't seen the science, the white papers, the evidence-based medicine. Ozone is very harmful to our lung tissue. It's inflammatory. It's very, very nice up in our atmosphere. We don't want that ozone to go away, but we don't want to breathe it. So I don't know how these air scrubbers work by making ozone and cleaning the air without, in a controlled way, without hurting our respiratory system. I think they're too new. I probably wouldn't go that route yet. More to come, hopefully, when real data is available. There were some studies that I looked at. The researchers said that if you overventilate, now let's take a second and review what ventilation is. Ventilation is not running your furnace to cool or heat your house. Ventilation is getting rid of stale indoor air and bringing in fresh outdoor air. Okay, so ventilation is introducing fresh air into your living or work environment. So if you doubled the rate of ventilation above the ASHRAE recommendation for your facility, there wasn't much of an effect on DALYs. Your health isn't going to go up very much. But if you cut it in half, there's a significant increase in DALYs lost. So my suggestion would be obey the ASHRAE standard, you'll be fine. Now, the studies also showed that for really, really small stuff, that PM 2.5 or smaller, an upgrade in filtration, in other words, a MERV 8 going to a MERV 13, had a much more significant effect on DALYs loss than an increase in ventilation rate over the ASHRAE standard. We're going to probably contradict that information here in a moment, not the filtration, but the ventilation. Virginia Smith at mansionglobal.com summarized some information from both ASHRAE and CIBSE, which is the Chartered Institute of Building Services Engineers. We're talking about the COVID-19 pandemic. Now think for a moment about a large apartment complex, a high-rise building. Some of that air, if you have forced air, some of that is recycled from other units. You can't get away from it. Okay, you can, if you build today, you can compartmentalize everything. We'll talk about that in video 3. But in a building that was built 30 years ago, let's say, or before, you're going to have some recycled air. So these two organizations in the COVID-19 era recommend increasing the ventilation rate. Now, just in the previous slide, I told you increasing the ventilation rate doesn't result in a reduction in DALYs. But with COVID-19, you want to make sure that you have as much fresh air as possible. This is kind of uncharted territory for all these organizations right now. And if you're a tenant in a high-rise apartment building, if you're a manager, if you're an owner, this information is should be very, very helpful, very, very useful to you. Along with that, if you're going to introduce more fresh air, there's an energy penalty. Okay, what does that mean? Well, when you bring in outside air, it's probably not the temperature that you want it to be. In the summer, it's probably hot, in the winter, it's probably cold. You have to condition it, so you're using more energy. But I feel that we should err on the side of caution, and fresh air is better in this era. There's a Forbes writer, if I can say her name, Alexandra Sternlicht. She says we should turn off the AC and open the windows to avoid this recycled air. Now, I disagree with that for many reasons, but some of the reasons are you're not going to have conditioned air coming in if you turn off the AC and open the windows. I'm not against opening the window at any time for any reason. You're going to be bringing in things like in an apartment, high-rise apartment building, you may have little to no control over the filtration of your air. You may not have an individual furnace filter, but then again you may. And if you bring in stuff from the outside, if you live in a big city, are you going to have smog? Are you going to have polluted air? I don't know. Pollen and other things are going to become concentrated indoors. You have no control over that. Okay. So ASHRAE would tend to agree with me, and the reasoning that they give is that thermal stress. Okay, so if you're 90 years old and you're in a high-rise apartment building in a big city and it's hot and it's 90 degrees and so forth and very, very humid, you're bringing that air in, your body may not be able to tolerate that. You may have, it may threaten your life, and according to ASHRAE, increase infection risk. So there are differing opinions on that for different reasons, I suppose. Now, in conclusion for this segment, I want you to take a look at this picture before you read the caption to it. This is a picture of a furnace filter, and it's filthy. It's probably moldy. It looks kind of wet and deteriorated. All right. This was posted on a discussion group that I'm a member of, and it says people are running around wearing masks and their furnace filter looks like this. I'm not telling you not to wear a mask. If the CDC recommends that you wear a mask during these current times, then by all means, wear a mask. If a business owner says that you have to wear a mask, then wear a mask. If you want to for your own safety, wear a mask. I do in my healthcare setting. I don't think you'd hear me that well. I don't think it would be a very good video if I wore a mask for this video, but I'm wearing masks in my office right now and when I go into other places. But don't wear a mask and feel like all your air quality problems are taken care of or minimized or reduced. You got to be aware of what's going on in your furnace filters, and the indoor air quality, and just don't be that person. So if you have questions for me, I welcome them always. If I don't have the answer, I'll get you an answer. Email is lee@ceassets.com, and you can also visit the practice website, NewtonEyeCareCenter.com. My own personal website, drleenewton.com. That will be live end of June 2020. Thanks again for watching. Thanks again for paying attention. We'll see you next time in video 3.